Hi everyone, Assalamualaikum. In this video, we are going to continue with evaluating limits when limit x approaches a fx over gx equals to 0 over 0, right? In the previous video, as long as the answer gives a real number, we can use direct substitution to evaluate limits. However, not all limits can be evaluated by direct substitution, right? Now we look at example 3. Find limit x approaches -1 x cubed plus 2x squared plus x over x minus x cubed. Let's say we solve this problem using direct substitution. Okay? We just plug in -1 into variable x here. So we get this. Okay? Then we simplify, we get -1 cubed equals to -1. -1 squared equals to +1. -1 cubed equals to -1. -1 cubed means -1 times -1 times -1. Okay. Then we simplify, so we get -1 plus 2 minus 1 over -1 minus times minus equals to positive and then 1. Yeah. After we simplify, we get 0 over 0. Okay. This is indeterminate. Okay. Or error. Right. So, in this case, we can't evaluate limits by direct substitution. Right. Now, we look at the correct method to solve this question. From the given question here, since after direct substitution, we get 0 over 0, and since there is no term containing third symbol and no terms containing trigonometric function, so we need to factorize. Okay? We are given fx and gx in polynomial. Okay? Right, so from here, after we factorize, we get this. Okay? We can factorize x from both numerator and denominator. Then, we can cancelling x from numerator and denominator. After that, we get this. Okay, limit x approaches -1, x squared plus 2x plus 1 over 1 minus x squared. Okay, let's say we try again using direct substitution. So from here, after direct substitution, we plug in -1 into variable x here. So we get this. Okay. We have -1 squared plus 2 times -1 plus 1 over 1 minus -1 squared. Okay, after we simplify, we get -1 squared equals to +1. 2 times -1 equals to -2 and then plus 1 over 1. And after that, we cannot multiply negative and negative sign here because negative sign here inside bracket with squared. Okay, so we cannot multiply negative here and negative inside bracket here. Okay, but we need to solve squared first. Okay, -1 squared equals to +1 and we still have minus sign here. Okay, and after we simplify, we get 0 over 0. Okay, which is error. What? Still 0 over 0 after direct substitution? So, we need to factorize again. Okay? So, after we factorize quadratic in numerator and quadratic in denominator, so we get this. Okay? We have limit x approaches -1 and then x plus 1 times x plus 1 over 1 plus x times 1 minus x. Okay? From here, x plus 1 is actually equals to factor 1 plus x. So we can cancelling, right? So after that, we can write limit x approaches -1 and then x plus 1 over 1 minus x, right? From here to here, since we factorize twice, we also can factorize like this. From the given question here, we are given cubic function in numerator and denominator. So we can factorize like this, right? And after that, we can simplify x in numerator and x in denominator. And we can also simplify x plus 1 and 1 plus x here. Okay? And after we simplify, we get limit x approaches negative 1, x plus 1 over 1 minus x. Okay? We get back this function. Right? Right, so from here, we can use direct substitution. We just plug in negative 1 into whatever x here. So we get this. Okay? And remember, after direct substitution, no more limit expression. Right? And after that, we can write negative 1 plus 1 over 1 minus times minus equals to positive sign. So we get 1 plus 1 and then equals to 0 over 2. 0 over 2 is okay because this is not 0 over 0. Okay? Using calculator, if you calculate 0 over 0, it will give 0. Right? So this is the final answer. Right? Got it? Now, we continue with example 4. Find limit x approaches negative 4, 1 over x plus 1 over 4 over x plus 4. Okay, from here, we are given fractions within fraction. Let's say we try to use direct substitution. Okay, from the given question, where fractions within fraction, after we use direct substitution, we just plug in negative 4 into variable x here. So we get this. Okay. Then we get negative 1 over 4 plus 1 over 4 over minus 4 plus 4, which is equals to 0 over 0. Right? And it is error. Okay. We cannot use the direct substitution because the numerator and denominator would be 0. Right? If there are fractions within fractions, first try to combine the fractions, right? From the given question here, we can write, we standardize the denominator here, so we get 4x, okay? And then we have numerator 4, we multiply this, so we get 4 plus x, okay? So we have fraction, and then within fraction here, okay, over x plus 4 here, okay. Right, after that, from here, we can write 4 plus x over 4x times 1 over x plus 4, okay. Why we get this, okay, because from here, okay, we can write limit x approaches negative 4, 4 plus x over 4x, and then per here means divide, okay? Divide by x plus 4. And divide by x plus 4 means divide by x plus 4 over 1, okay? And then we can change to multiplication, okay? When we change to multiplication, we need to exchange numerator and denominator here. So we get x plus 4 over 4x times 1 over x plus 4. Okay? And after that, we can simplify 4 plus x and x plus 4 here. Okay? We cancelling. And after we cancelling, we can write limit x approaches negative 4, 1 over 4x. Okay? And then from here, we can use direct substitution. We just plug in negative 4 into whatever x here. So we get this. Okay? And remember, after direct substitution, no more limit expressions. Alright? Then we simplify, so we get 1 over 4 times negative 4 equals to negative 16. So the final answer equals to negative 1 over 16. Okay? So this is our final answer. Okay, negative 1 over 16. Right? Got it? Now we continue with example 5 under evaluating limits using factoring and cancelling. Find limit x approaches 0 e to the power of 2x minus e to the power of x over 1 minus e to the power of x. Okay? Let's say we use direct substitution. Okay? From the given question here, when we use direct substitution, we just plug in 0 into whatever x here. So we get this. Okay? E to the power of 0 minus e to the power of 0 over 1 minus e to the power of 0. Right? Then we get e to the power of 0, any numbers, the power of 0 equals to 1. And then minus 1 over 1 minus 1. Right? From the properties of indices, any value to the power of 0 will equals to 1. So that's why we get this. Okay? And then after we simplify, we get 0 over 0, which is error. Right? So we cannot use direct substitution. Okay? What should we do? From the given question here, we can write this. Okay? We can write e to the power of 2x equals to e to the power of x times e to the power of x. Madam, why e to the power of x equals to e to the power of x times e to the power of x? From properties of indices, a to the power of m times a to the power of n will equals to a to the power of m plus n. Okay, so if we have e to the power of x times e to the power of x, we can write equals to e to the power of x plus x. And after we simplify, we get e to the power of 2x. That's why we can write e to the power of 2x equals to e to the power of x times e to the power of x. Right? Got it? Right then, from here we have same term. Okay? So, we can write equals to limit x approaches 0. We can factorize e to the power of x here. And then in bracket, we have e to the power of x minus 1. Right? So that when we expand, we get back this. Okay? E to the power of x times e to the power of x equals to e to the power of 2x. And then e to the power of x times negative 1 equals to e to the power of x. We get back the given function here. Right? Then we can cancelling. Okay? Wait! Are you sure can cancelling? Look at this. We have e to the power of x minus 1 and 1 minus e to the power of x. E to the power of x minus 1 is not equals to 1 minus e to the power of x. So we can't cancelling, right? So please be careful. E to the power of x minus 1, we can write equals to, we put minus sign and then we put bracket and then we exchange ex and 1 here. Okay, so we can write equals to negative bracket 1 minus e to the power of x. Because when we expand negative and bracket here, we multiply negative and 1 here, so we get negative 1. And then negative times negative e to the power of x, we get plus e to the power of x. Okay. So from here, it is equals to left hand side. Right? Right. So from here, we can write this. Okay. So equals to limit x approaches 0, negative e to the power of x, bracket 1 minus e to the power of x. Okay, we write e to the power of x minus 1 equals to negative bracket 1 minus e to the power of x. We exchange ex and 1 from here. Okay. To avoid mistakes, you better put a negative sign in front rather than you put between e to the power of x and bracket here. Okay, this is because if we put minus sign here, this means minus operation. But we want to write multiplication by negative. That's why we put in front here, right? To avoid error. Right? And from here, now we have same factor. Okay? So we can cancelling, right? So we get this. Okay? And at the same time, we can move out constant negative. Negative here means times negative 1. So we can move out from limit expression, from the properties of limits. Okay? Then we have limit, we have negative, and then limit x approaches 0, e to the power of x. Okay. After that, we can use direct substitution. Okay. And remember, after direct substitution, no more limit expression. Right? And when we use direct substitution, we just plug in 0 into whatever x here and no more limits. Okay, but we still have negative sign in front here, right? What is E actually? E is an Euler numbers. Okay, and E equals to 2.718 something. Okay, it is an irrational numbers, right? And any value to the power of 0 will equals to 1 from properties of indices. Okay, then the final answer equals to negative 1. Okay, this is the final answer for this question. Right? We cannot use direct substitution, but we need to factoring and cancelling. But in this case, before we factoring, we can split using the properties of indices. Right? Got it? Coming up next, method 3 to evaluate limit. Evaluating limits using multiplying by the conjugate. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.